Hello and welcome to SGN Tech Forum. I hope you guys are staying safe and learning a lot of new things during this COVID situation. That is the best thing we can do, right? So this is the second video in Docker container series. In my first video, I shown you how to work with Docker containers, that how you can pull the images, how you can run your container, attach to your container, start, stop, and exit out of the container. So container itself is like very fascinating, right? But when you spin up your container, it need to talk to outside world, right? So that's where the Docker networking comes into picture. So as you can see in my screen, there are two requirements, application requirements and then the networking environment requirement. They both are different, and in between you have Docker networking. So and in CNCF terminology, Cloud Native Forum terminology, we call it Container Network Model, or CNM. CNM broker connectivity for your Docker container, and also it abstract away the diversity and complexity so common in networking. So very heavy sentence, but what it means is like CNM enable your Docker to talk to outside world or within the Docker ecosystem. The result is portability, which is one of the core strength of container, and there are two type of network drivers, Docker network drivers. Native drivers, that mean when you install Docker, you'll have some native network driver available, and I'll show you what are those. And then you have the remote network drivers like Calico, Cisco Concave, etc. So in this video, we are going to focus on native network driver. There are 5 types of native network driver, and they all have their own use cases: host, bridge network driver, overlay network driver, MAC VLAN network driver, and none. So they all have different use cases. Let's understand what all they. So host network is container uses networking stack of host. That means it's kind of like direct. It can see all the interfaces of the host directly. No namespace separation. All interface on host can be used directly by container. So this is like you are installing it on bare metal and you are seeing everything. Then you have bridge network driver, which is most common and popular solution. The bridge network driver creates a virtual Linux bridge on the host that is managed by Docker, obviously. By default, container on a bridge can communicate to each other. So if you have two hosts connected to the same, two containers or host connected to the same network bridge, they can talk to each other. Overlay network, you can think of it's a combination of bridge network and VXLAN overlay. So it uses and the use case is multi-host networking. So if your container span across multiple bare metal chassis, but they still form a cluster or something, then you need multi-host networking, and that's where it uses a combination of local Linux bridge and VXLAN overlay container to communicate over physical network infrastructure. MAC VLAN driver, this is my favorite and most innovative one. Let's read it. You can use MAC VLAN bridge mode to establish a connection between container interface and a parent host interface. It can be used to provide IP address to the container that are routable on the physical network. So these IP addresses, container IP addresses, can be routable all over your network. Additionally, VLAN can be trunked to MAC VLAN driver to enforce layer 2 container segmentation. So you can trunk, you can VLAN, other than just IP address, you can also assign VLAN so that you will have layer 2 segmentation. Once you read this sentence, the first use case which comes in my mind is app hosting, right? So Cisco IOS app hosting, if you see when we enable containers on Catalyst 9000, this is the networking driver they use, MAC VLAN driver. and then none. So you'll see that why none. So none, that means driver gives container its own networking stack and namespace separation, but it does not, I mean, it isolate from host networking. So you have namespace separation and networking stack, but this is just limited to the container environment. It's not exposed outside. So now let's go and do a live demo how to work with this understand different networking drivers and see how to work with them. All right. So this is my local desktop where I have Docker installed. I am logged into Docker repo. So let's see what container I'm running. Docker ps, no container, and what I have in my image repo. So these are the images available locally. We are not going to work with any of this image. I'll create a separate image. Now let's see what are my default network. So yeah, as you have seen earlier, so we have bridge, we have host, and we have none. These three network driver comes by default. If you want to inspect what is configured for this, so let's check bridge, network inspect bridge. Name is bridge, there is an ID for that, and you see the subnet and the default gateway. So this is a local bridge which is part of this 172.17 subnet, and the gateway is by default is 17.1. So any host you spin up in this container environment, they'll get IP address from this subnet, and their gateway is going to be 17.01. So this is the by default thing. Okay, now let's see when you spin up a container what happened, right? So let's start a Ubuntu container. That's best idea. Okay, I don't have the image locally, so it should reach out to Ubuntu. Okay, unable to find image locally, and it is pulling from Ubuntu library. The image has downloaded. Let's verify Docker images. Okay, sorry. When you do Docker run IT, that means you are already in the shell. So if you want to confirm, allow. Sorry about that. PWD. I'm on root, and so I'm already attached to container in the bin bash, right? So let's see, my container is running. Let's see what networking I received when I spin up this container. You see, if config is not there, that means there is no networking stack on this container by default. So we need to install the networking stack. So let's do that. First, let me do apt-get update to this newly installed machine so that I get all the repos. Okay, and then I'm going to say sudo apt installed nettools. Sudo command is not found by default. It's because it's a bare minimum image, right? So I do not have a sudo here. So let's first install sudo. And then I'm going to install nettools. Now you see, since I have installed networking stack, I do see interfaces, and you can see Ethernet 0 has got 172.17.0.2. So my bridge has a address in this subnet, and that's the second IP address I got. So it started receiving the IP address as soon as it has a network interface. All right, so far so good. Now, so this is on Ubuntu, right? Now if you want to create your own bridge, you can do that. If you want to restrict to your own subnet, like you don't want to use 172.17, you can also specify your own subnet. So now let's exit out of the container. To exit out of the container, the escape sequence is Control P and Control Q. In this way, you will be out of container without killing it or stopping it. So you can see my container, Ubuntu container, is running. So now let's create another bridge, and then as a part of demo, I'm going to create two different container, attach it to the bridge, and see if they can talk to each other, right? So let's create a bridge. To create a bridge, you are to Docker network, create bridge SDN Tech, since SDN Tech Forum is our channel. So let's use that name. Okay, a bridge is created. Let's verify if the bridge is created. Network ls. So now you can see there is a new bridge created, right? As the new bridge created, let's inspect this, what we have under this bridge. Okay, so you can see the same thing, that we have name, ID, and the scope, but look at the subnet. Now it has accepted a incremental subnet. Earlier my default one was 172.17. Now as I create a new bridge, it is taking the next subnet, 172.18.00/16, and the gateway is going to be the first IP address, 172.18.0.1. But if you want, while creating the bridge, you can also specify subnet, but I'm going to stick to the default one. Okay, now let's create two containers and attach it to the bridge. So as you have seen that Ubuntu container freely available, but it's lack a lot of basic things, because obviously when you want to spin up a container, you want a networking stack to be installed. So that's why there are variant of Ubuntu which are available. So BusyBox is one version which has all the networking stack installed. So I'm going to say docker run itd and see .net -net equal to SDN Tech. That means I'm saying that, okay, create my Docker container and attach it to this bridge. Name is box1. So I'm going to say box1, and the type is BusyBox. So BusyBox is a Ubuntu container which has a networking stack installed, just like Kali Linux has all the security portfolio installed. So let's create this Docker. Okay, invalid reference format. Okay, am I doing any spell check wrong? Let me check. ITD. Okay, so maybe I'm doing some syntax error here. Let me stop. Okay, so as you can see, we have created a new container called box1. Previously I was doing some syntax error. You have to have two dash. So my container is created here. Now let's create another container, box2. So both the container created. Let's see what I'm running. Sorry, PS. All right, so you can see previously we created Ubuntu, but now we are going to work with BusyBox1 and BusyBox2, box1, box2. Let's connect to them. So Docker attach, okay, and let's verify since it has already networking stack installed already, so if config should work. Let's see. So it has got the second IP address 18.2. Let's exit out of this. So the escape sequence is Control P, Control Q, and attached to box 2. Again, let's see what IP address it has got. It has got IP address 3. So you can see both of them has got the IP address in the subnet of SDN tech, and let's see if by default they can talk to each other. So I'm going to ping box 1 from box 2, and as you can see they can ping each other. So this is a bridge type of network, and by default the container attached to the bridge network driver, they can talk to each other, and this is what I am showing here. So based on your use case, choose your network driver, whether it's a native driver or some advanced one, remote network driver, and start exposing your container. So I hope you find this video useful, and if you like it, please click on the like button and subscribe to the channel. Thank you very much, and stay safe.